So I hope everybody could hear that. I just got a message that my internet was unstable. So you may not have heard what I was saying. Basically, if you have any questions, pop them in the chat, and we will take them later. And I will hand over now to Roberto.
Okay, thank you, Anne. Hello, everyone. I'm Roberto. I work for Zetali. I have been doing pre-sales activities at Zetali since the beginning of 2018. I have been living in France, and just 1 month ago, I moved to Lisbon. So I'm talking from Lisbon right now. I hope everybody stays safe at home with the situation of COVID. And the idea here today is to talk a little bit about storage, mainly about disk storage, and the different information that we can collect to do analytics with storage main KPIs. Okay. So the agenda here, we'll walk through log analysis, some SMF records, and then we'll talk about the SMF records address to disk storage. In this arena, I split the subject in 4 items. When I talk about system topology, performance, of course, capacity, and chargeback. And after we do a recap of everything that we will see during the presentation, and we'll have question and answers at the end. Feel free to send questions through chat, or if you prefer, you can unmute your device and ask me the question direct. I don't care. Okay.
Just to say that
so talking.
Everybody is muted and they cannot unmute themselves. So put the message.
Okay, sorry.
Chat.
So only at the end.
Yeah. Well, no. If they put it in the chat and they want to have a conversation, if they say so, then I can unmute them. But we keep everybody on mute throughout the session.
Okay. Perfect. So before starting, I would like to explain first who is ECOST. So Zetali, sorry. Zetali, it's a French company founded in 2006, based in Nantes, France. Have offices in Paris as well. Have a global presence through Alliance. We have more than 60 customers around the world. And we actually work with the mainframe environment. So we have solutions for mainframes, ZOS mainframes. Basically, we have 4 solutions, all of them covered by Zetali umbrella. We have solutions for cost control, automated capping, service intelligence, that's analytics solutions, and also resource planning. That's a solution for capacity planning, where you can simulate and do what if on your configuration and simulate different workloads, this kind of thing. Okay. But now our subject today is to talk about logs and ZOS analysis. So the ZOS provides a lot of interesting information that we can use to investigate, analyze, do capacity, do performance, whatever subject you want to address. You have logs available on the system where you can use them to extract information you need. So there we can get information to analyze possible bottlenecks, problems with performance, cost reduction opportunities, and also have a knowledge and understand the behavior of the system. So, and then talking about the SMF records, we have more. We have 255 different SMF records related to for each event that you execute on the ZOS. So those events are generated. Those SMFs are generated every time you execute a job, you log on to SEO, or you write a data set, or you read a data set. So um, for everything, SMF is generated. But not only events, some products generate SMF records as well. So the first 128 SMF records are related to the system or products, core products from IBM, and the other 125, 26, 27, sorry, are related to different products and ISV products or IBM products. So there you have, on those SMF records, you have all information needed, but it's not ready to be used. That's the main problem, because you have to access the data, and usually the data is in binary, so you have to translate that for something understandable. And for that you need knowledge, because you need to understand how to translate things, and expertise to decrypt all the fields you have on the SMF record. Okay. So there are some shops that SMF records represent a huge amount of data. So depending on how is the environment, you can have billion of SMF records per day. So it's complicated and complex to collect all those SMF records, store them. Usually you store the SMF records in tape data sets, and when you need to manage them, when you need to read them to generate a report, it's really complex. So apart from that, you have the data, it's all binary. So you have to translate that, you have to convert to character or date and time or number, depending on the information, to understand what it means, the information. And another difficult thing is to correlate, because in one event that we execute in the ZOS, it can generate many SMF records. And to have a good information about that event, sometimes you need to correlate them, and that's difficult to do. So you need to have expertise to do that. And that's why I put on the bottom, so it's time consuming, because you need some time to understand the structure and how to deal with those SMF records. So this is just out of curiosity. This is an example of a SMF record. You see, so you can translate something from here. So few things. Oh, perhaps an LPAR name or a system ID, a version of ZOS. So a Plex P should be a sysplex name, but more than that. So you cannot see in just looking at this screen. So that's why I was explaining that's difficult to deal with SMF records, because you receive this kind of information related to those records. And an interesting information that the SMF records are available since 1969, when the IBM 360 was released. So apart from difficulties, let's address the SMF records to storage. So with those SMFs, we can get a great picture from the storage environment and get really good information on performance perspective. Not all shops use those SMF records to address those things, but it's really important when you have this information available that can be used to analyze performance, capacity, and other stuff. So today, the main softwares that generate the SMF records related to storage are RMF or CMF monitor. Depending on the shop, you have one or other. The most of the SMFs that I will talk about in this presentation is related to these two, is generated by this one of these two softwares. So when talking about the SMF records address to storage, I split them in two groups. So the first group is the storage components, which address each component of the ZOS of the storage structure. So here we have in the first square here, we have the SMF 73, 74, and 78. The component is channel path, device, cache, FICON director or switch, and LCU. And the second group, it's more logical, and it's where the users most use this information, that is volume and data sets. And for this group, we have the 14, 15, 42.6, and 64. We have other SMFs that we can use to address those two groups, but today we will focus on those SMFs that I think we can extract good information on storage area. So apart from SMFs, when talking about capacity, we have the decollect. The decollect is an option from IDCAN's utility that maps the volumes you have on the environment and generate flat files bringing information about usage of volumes and also data sets. And during this presentation, I will explain how we can use this important information when you want to address capacity. So the storage components here, we have the left-hand side, we have the components, the disk storage components. So the disk storage array, the cache, the channels, and the logical units. And on the right-hand side, we have the logical part where we say it's missing on the left, actually, the device. Because the device is a physical component. And on the right-hand side, we have the logical part that address volumes and data sets. And also, of course, because many shops work with storage groups, that it should be on the right-hand side to express when we are analyzing the KPIs, we need to analyze then looking at the storage groups as well. So after I show the SMF records, the groups and the components, so let's split again the analysis into four items here. The system topology, to understand the configuration of your environment and the connections you have from your Z machine to your storage. The second topic here is the performance, the main KPIs that can be used to analyze the storage performance and to see how your storage is performing. Also, the third topic, disk storage. So in this part, we'll talk about capacity and chargeback. As soon as you know the capacity of all your entities, so you can charge back your internal customers or external customers, depending on the environment. So let's go to system topology first. System topology. So see if you correlate the SMF records that I show in the first group, the storage components, that means the SMF record 73 to 78, you can create views like this, like I'm showing here. So on the left-hand side, we have the physical view, where we start from the mainframe, so the Z machine here. So, and then you can understand your channel subsystem ID, the channels you have, okay? So you have the mainframe, the channels you have, the arrays where the channels are connected, the SSIDs, and then you have the volumes. So you can, correlating those SMFs, you are able to produce this kind of tree to understand the connectivity between your mainframe, your Z machine, and your storage array. Or you can do a tree like this on the logical view that's on the right hand side, where you start from the Z machine again, but now it's per LPAR and then per storage group, and then you have the volumes inside the storage group. So you can map which LPARs are accessing which storage groups and in which volumes are related to each storage group. So correlating those SMFs, you are able to produce this kind of information. When talking about storage performance, we have many KPIs for I/O. So we have KPIs from ZOS point of view, and also when looking at the cache, you have KPIs for the backend. But today we are talking about IOs for the ZOS point of view. So I listed here some of the main KPIs that can be used to address performance. So IOPS, response time, cache IO distribution. When I talk cache operations, it's the IO distribution, what type of IO you have on the environment, and the IO time for read and writes, the contribution of each one. The one important thing, that's the channel activity. So you need to understand the throughput of your channels to see if you are performing well or not. On the devices, you have the connect, pending time, busy times, and CMR to understand the entire path of the IO, and also the physical times. What I said the beginning on the cache operations, you can address the back end to see the times on the IO on the back end. So this is an example here on the storage performance for IOPS and response time. So using the SMF records produced by RMF or CMF, you are able to produce this kind of charts. So here an average IOs per second, average response time, or you can break down by storage group, for example, and you have the same information, but now by storage group. And then you can understand which storage group is producing more IOs per second on the same way the response time. You can, if you break down by storage group, you can understand which is the response time of your storage group. In this case here, you see in the first one, we have the DB2, SG DB2P1, that should be a DB2 storage group. And the response time, it's a little bit high in milliseconds, so sometimes we need to review to see if it's good for the environment or not. Nowadays we have all flash disks that the response time is decreasing a lot. It's 0.5 milliseconds is sometimes a great number, or it's very high in terms of response time when talking about all flash disks. And also you can see the same information by volume, where you can understand how each volume is performing on your environment. On the cache operations, one nice thing you have using the SMF from Catch is to understand the behavior of your IO. So in this example here, I classify the different types of IO. So the handle IOs and sequential reads and writes, and here I make a distribution, a contribution of each type that passed through the SMF record. So I have the read hits, the read misses, the writes, the sequential reads, and the sequential writes. And here I have the contribution of each one in average, and hour by hour, you can list, this is an example, of course, you can list the distribution of your IO and understand how it works on your environment. So you see here, for example, that the handle writes happens more during the day than during the night. So it should be databases writes. And also here on the right-hand side, we have the IOPS, so the distribution of read and writes, where you can understand if your environment it's more read or write oriented. Another subject on the performance is the channel. As I said, you need to understand the throughput of your channels. So we have one specific SMF for channel where you can understand, you have many KPIs on this SMF. And one of the main KPIs here is the megabytes produced by the IO. And then you can calculate the read and write megabytes, the total mega or gig or terabytes, depending on the periodicity you are using. And also you can see the HPF exploitation because if you can see if you are having problems, because if you are having a lot of HPF misses, means that you are not performing well and you need to check what's going on your storage array. A graphical representation of the channel activity where you have the information read and write stacked, so you can understand the contribution of the contribution of the read or write and the throughput on each interval here in this specific day. So you can see that you are producing the throughput of your channels are 1.800 megabytes per second. On the device activity, we have the connect, and pending time components. And this is another graphical representation of those KPIs that can be used. So you can calculate the time spent on each component. And in this example here, I have the connect, disconnect, and pending time stacked, and the IOPS on this blue line, and the representation of the amount of IOPS is on the right side here. So as soon as you have all the KPIs available, so you calculate, you grouped, you can apply analytics. So here I show two examples of analytics that you can apply. So in this first example is anomaly detection. I have here the average IOPS, and if you apply a formula for anomaly, so these black bars represents the anomaly in this amount of data. So to apply this kind of thing, you have to have a model, good amount of days with data, around 2 or 3 months of data, so you can apply those formulas, and then you are able to produce this kind of thing. I know that's really difficult to apply this kind of formulas. So you can use Python, R language, or any other formula to apply that. And there are some suggestions on the internet how to use those formulas, and you can apply that for everything. Sometimes, in this case of IO, a low IOPS does not represent anomaly sometimes. So you have to keep in mind that sometimes you need to adjust your formulas to have a better understanding of what is going on with those numbers. And also you can apply statistics. So in this case here, I applied the local estimate where I'm receiving the minimum, maximum, standard deviation, average about the response time activity. Okay. So another topic, that's dataset performance. So for dataset performance, we have some SMFs that I listed in the beginning. The SMF 14 and 15 are from non-VSAM datasets. So those SMFs are related to input and output operations. So you can understand the attributes of the dataset and the usage of it. So you have the number of EXCPs, the use count, the dataset attributes, or primary location, secondary location, the DCB, etc. So you have the attributes of the dataset, and using the SMF 42.6, you have the IO performance for the datasets. In this example here, I'm using the ARC logs that are flat files, sequential files from DB2. And I'm showing here in the first table the EXCP count from each data set. And on the IO perspective, on the performance perspective, I'm showing the response time, connecting time, pending time, and other KPIs for the same data set. Okay. For VSAM, we still using the SMF 42.6 for IO performance, uh, for IO performance. And for usage, we use another SMF, that's this SMF 64 that is created during the close of the VSAM. So, and here you have interesting information that's the usage. So you have the number of deletes, inserts, updates, retrieves of each visa. And also you have the CA splits and CI splits that can be used to define if you need to do a reorg on this data set or not. Depending on the installation, there are installations that run reorg procedures during the weekends to reorganize the VSAM files. And for IO performance, we have the same KPIs for non-VSAM. We have the same KPIs for VSAM as well. So response time, connect time, painting time, IOs, etc. When talking about DB2, there is another thing that's really nice to see. That's the VSAM files when using the SMF 42.6, because usually on the dataset names, you have the DB2 attributes. For example, in this example here, I have the database name here on the third qualifier, the table space or index space, that's the fourth qualifier, and the partition number, that's the sixth qualifier. And the first qualifier, I have the application name. So in this case, it's easy to understand, to group the data name to see if the performance is going well or not. But the main point here is that you can analyze the IO performance of the data sets from a specific database. So this is really nice because you can follow up and see if the data sets are in a good location where the volume it's responsive, or you need to change it to a better disk or a flash disk, etc. So this is a good point of analysis, and because of DB2 has the names on the dataset qualifiers, it's easy to understand from which database you are working with. So talking about storage capacity, we can use the decollect V records. Why? Because on the decollect V, you will generate a flat file with the information from each volume on your system, and then you can do many analysis. And always you can group all those volumes and understand the capacity of your storage array. In this example here, I have the total capacity, the free space, and the capacity used. So you can easily understand the usage of your environment. And also, if you group that by storage group, and in this case, I'm looking at free space, I can see which storage groups needs my attention, because you need to include more volumes or do analysis to remove some data sets from here to put in another place, depending on the environment. Also, you have the information about the allocation, the free space, the fragmentation. So you have many information here that can be used for these analysis. Okay, and you can group them also by storage group. The fragmentation, I put a star here because depending on your storage device, you don't need to do fragmentation anymore. So the volume is becoming too logical that even if you have many tracks spread on your storage array, because it's so logical that you don't need to fragment to defrag this to have all the tracks aligned again. So depending on the storage, you don't need to run the frag anymore. So when talking about data sets, there are two sources of data that you can use to calculate capacity. The SMF 14 and 15 can be used to calculate because it brings the dataset attributes. So you can calculate the primary area with the secondary, and then calculate the size of the data set, but it's not precise. If you want to be precise, you need to use the decollect, because with the decollect, you have a scan of your disks, and you receive the right information about the size of your data set stored in each volume. So, and then when you use decollect, you have all information about the size, and it's precise. But when you use 14 and 15, you have other KPIs that can be used, like use count, extents, and the time that was generated, and this kind of thing. Okay. So now talking about chargeback. When you know which storage groups, which volumes, which data sets you have, and the occupation of all of them, so you can group those entities, I would say, to calculate the amount of gigabytes of each group. So knowing this amount of gigabytes, you can charge your internal customers. Why not? Depending on the company, it's possible to do that. And this is one example of chargeback, where you have so for a storage group, it's easy because it's just a group of volumes, and then if you send the volumes, you have the amount of gigabytes per storage group and per volume. And per for data sets, you can group them by DSN patterns. So in this example here, I have 3 different patterns that I use to get the application name, because I have the application name in the part of the data set. So the data set p.xxx, where is the application name? So I group all of them, and I have the amount of gigabytes used for this application. In other example here, I have the brb12.ccsis xxx, where I can use to group the total amount of gigabytes for this application. Okay, and so forth. And also here I put the current activity each day by day, but also you can forecast that. You can predict and see in the future, according to the historical information you have, you can predict, for example, to see the amount of gigabytes used for this application in 10 days, in 1 month, according to the historical information you have. Okay. So, passing through all those topics about SMFs and performance, capacity, chargeback, and topology, doing a recap here. So to do performance and topology, the most used SMF records are listed here for storage groups, device, channels, hyperpath, that's the device as well, and FICON directors and data sets. When talking about capacity and chargeback, we usually use decollect V and D. The decollect V is not so does not consume many CPU cycles to execute, but the data set, yes. The data set, because it maps all the volumes and all the data sets in the environment. So you have to take care when using decollect more than once a day, I would say. Usually the companies execute decollect once a day or not much more than once a day. And the dataset usage, we have the non-VSAM datasets 14 and 15, and for VSAM datasets, the SMF 64. Okay. Here, if you want to know more about our company, please visit our website, www.zetali.io, and then you can discover how we can deal with the huge amount of SMF records and which kind of information we provide to our customers. Thank you very much for this time. And Anna, I pass over to you right now.
Get my unmute. So thank you, Roberta. And if there's some questions, yes, we have a question from Andy Gray. He says, fragmentation is important as that is what ZOS sees. This leads to more storage being required and additional work on iOS component of ZOS. IBM still provides defrag, DFDSS.
Yes, yes.
I think that was a statement more than a question. But
yeah, it's a statement. Yeah, it's true. They're still providing the defrag, but there are some situations that you don't need to execute these anymore. But of course, it's still available because you have different types of storage arrays on the market, and depending on the storage, it's important to run the frag on weekly basis or month basis.
Okay, I have set up the session so that you can unmute yourself. So if you want to talk to Roberto directly, if you don't want to speak out loud, you may still put questions or statements in the chat, and I will read them out instead. I may not give them the right emphasis. Storage isn't my bag. but I will do my best.
Hi Anna, it's Andy Gray. It was just really, as I point out, it is more of a comment, but it's something that there is a correlation between volumes that are fragmented and storage groups that are badly fragmented, and additional work, with iOS. So therefore, that drives up the CPU utilization, and it's very hard to measure that because there's no SMF record cut to actually show what work iOS is actually doing. So it's sort of like a hidden impact. And also it impacts the rolling 4-hour average, which is where the software costs come in as well. So it's an extra thing on top of it. It's sort of like a layer on top of a layer of a layer. It's a hidden overhead, effectively.
Okay.
So no way to find it.
It's unfortunately it's not something that's reported. There's no SMF record that's cut. You can only really get an idea of what's going on is if you use something like a Megamon.
Yeah.
Which is, you're then really getting into the depths, yeah.
Yeah, I haven't used a Megamon since I was an operator in the 80s, so I'll trust you on that.
It's interesting, actually. You actually come from the same area as I come from, or where I am actually now.
Okay.
So I noticed I looked on your LinkedIn profile because I hadn't seen your name before. Where you grew up is where I am currently now.
Right.
And you have your CV is very, very similar to mine, but it's quite amusing actually.
Yeah, there was 22.5 years at where you are now. So from operator to in quotes SysProg. So
yeah, no problem.
Yeah.
And I even know what Zeek and Zach and Zara are as well.
You sorry?
I even know what Zeek, Zach and Zara are.
Oh, okay.
Yeah.
Yes, but that's ASG.
Yes.
Yes.
I'll be quiet now. Thanks very much, Roberto. Thank you for your pitch. Very, very interesting.
Yeah. Yes.
Okay.
Thank
you
Roberto.
very much.
Yeah, and thank you everyone that attended. Please provide feedback both to for Roberto to give him feedback on the session itself, and also we use that to look at next year's conference and the sorts of sessions that we like to put together. As those of you that have attended GSE conferences in person in the past, you'll know that we have magnificent raffles where we managed to put together a lot of money for charity. Obviously this year that's virtually impossible, so we greatly appreciate any small, just imagine you're buying a strip of raffle tickets, £1 in the bucket. Just if you can provide a little something for our NHS charities this time. Don't forget as well, if you're hanging around till the end of next week or even not, there is also a conference feedback that you can complete. So there's feedback for the session and feedback for the conference, and believe it or not, I also have a chairman's feedback to put out, but you don't need to worry about that. And the charity, and you can get the feedback either by the QR code or on your bring your own agenda on the tile for this session. Just at the bottom there's a link there that you can use to go and put in your feedback. That's the one I've been using. It's been very easy. Okay, thank you very much, and stay safe.